Okay, so we talked about polynomial operations. You guys all cringe, but let's what are your operations in mathematics? Raise your hand and give me an operation in mathematics. What are your operations? Emily? Division. Division. Yeah. Okay. What are the other three you know very, very well? Tony? Addition. Addition. Wyatt? Subtraction. Subtraction. Multiplication. Guys, that's all we're going to be doing in this topic. Adding, subtracting, and multiplying. We're going to do dividing after break. Okay? Or a version of it, I should say, after break. Okay? The only difference is, instead of doing it with just individual numbers, we're going to do it with polynomials. Okay. Well, that's a good question, Alex. What is a polynomial? Okay. Well, do you guys know what the prefix poly means? P-O-L-Y. Raise your hand, please. Don't yell it out loud. Toby. Multiple or many. Okay. Nomial is another word for a term. Okay. So a polynomial is many terms. Okay. So terms are separated by plus and minus signs when you see them all listed out. Okay, we'll talk about that a little bit more here in just a minute. But these are going to have more than just one term in them. So the question becomes, how do you add them, how do you subtract them, and how do you multiply them? That's what this topic is all about. Okay? Before we can do that, we need to get some language down about how to discuss polynomials, because this language is going to carry over to Algebra 2 also in pre-calc and calculus and all those wonderful things you have looking forward to in your next 4 years of high school. Okay? So the language is going to be consistent. So we got to go ahead and take a look at a couple of these things. So we can classify polynomials, okay, by sorry about that, guys. Okay. We can classify polynomials by the number of their terms, first of all, but we can also just classify them by another feature called the degree. We're going to talk about that here in just a second. All right. Now, usually we would just go through here and try to figure out what these words are. I'm just going to list them for you right now. So you're just going to, I'm going to complete this table. Then you're going to take a picture of it. It's in your notes. Done. We're going to move on. Okay. So you might have heard some of these words before. Okay. If my polynomial has one term, it is called a. Well, now my pencil won't write. Okay. Well, I'll put it up here in a second. Now it is a monomial. Mono. Why are we calling it a monomial? Because what's the prefix mono mean, class? One. Yeah. See? Really took a lot of genius to come up with these words, right? Yeah. Okay. So, two terms, binomial. Three terms, trinomial. After three terms, we get lazy. Four more terms, polynomial. Okay? Grab a picture of that table. Everybody got it? Okay. Now, for our purposes, here's what's going to happen. For our purposes, we're going to focus on polynomials that just contain one variable in them. Okay, for the most part. We might do a little bit of multiplying with two variables, but that's not going to be so difficult, okay? For the most part, our polynomials are going to have just one variable in them. So the degree of a polynomial is the other way we can classify what we have, okay? The degree on a polynomial is the highest exponent on the variable. So if you have a lot of terms, okay, and they all have different exponents on your variable, the degree of the polynomial is the term that has the highest exponent, and the degree itself is the actual exponent, the highest exponent on the variable, okay? So, for example, if I have a term that is x to the fourth then the degree of my polynomial would be 4, because that would be the highest exponent on one of my terms. Okay? So you have to compare all of them and then determine which one's the highest one, and then that number, the highest exponent, becomes your degree. Okay? So here's the deal. If you have a degree of 0, which means the highest exponent on a variable is 0, as an x to the 0 power, then this is called a constant term. Now, have you heard of me use constant in here before, right? So guess what? These are just your general garden variety numbers, okay? Because what is x to the 0 power, class? 1. So that's why you don't see any variables with constant terms, because the power on x is 0, which becomes 1, and 1 times your number is just your number, okay? So that's called a constant term. You've also seen a lot of polynomials with degree 1. You probably didn't recognize them, though. Guess what? They are the linear polynomials. Now, you've seen those before, right? Yeah. Okay. That's just when you have like your x, the highest power on your x is 1. Okay. And all graphs of linear polynomials would then be what kind of graph? A straight. Bingo. Okay. Now it's going to get more interesting. Are you ready? For 2, we call these quadratic. Okay. And we're going to study those after we come back from break. Degree of 3, cubic. Degree of 4, quartic. And again, after 5, we get lazy. After 4, we get lazy. Excuse me. Okay, so after 4, we just say polynomial of nth degree. So whatever the highest exponent is, if it's higher than 4, we just say polynomial of like 7th degree if the highest exponent was 7, or polynomial of 10th degree if the highest exponent was 10. Okay? Are we okay with this table? All right. We're not going to spend a lot of time on this. In fact, I took out the homework problems that have you classify these. We just need to know the terms. It's not going to be tested or anything like that. But you still need to know what these terms are, because we're going to use them a little bit when we talk about things. Like if I say, hey, you need to multiply this binomial by this trinomial, then you know what I'm talking about. Okay? Or this monomial by this binomial, or whatever it might be. Or this quadratic term by this cubic term. Okay? So then you know what we're talking about here. Sound good? All right, so we're going to classify these polynomials 2 ways. Okay? We're first going to classify it by its degree. That's an adjective. Okay? And then we're going to classify it by its number of terms. That's a noun. Okay? So let's do it first, and then you guys take a picture with the answers on there. Okay? All right. On your fingers, on problem 1, x cubed minus 4x. Okay? On your fingers, show me how many terms this polynomial has. Number 1, x cubed minus 4x. How many terms does this polynomial have? Terms. Okay? There are 2 terms. Okay? There are 2 terms. X to the third is one term. 4x is the other term, because there's a minus sign between them. Everybody okay with that now? Now you know what you're looking for? Okay. Now, on your fingers, one more time. What is the degree of this polynomial? What's the highest exponent on your variable? 3 is the correct answer. Nice job. Okay. So by our tables on the previous 2 screens, this would be classified as a cubic by its degree, binomial by the number of terms. Ever see how that works? We okay with that? Good. Okay. So let's do it again. Number 2. Okay. How many terms? Show me a term count. Okay, on your fingers. Now we're catching on. Good job. What's your term count here? I see a lot of 3s. Okay. So what kind of polynomial is that? Monomial, binomial, trinomial, polynomial, trinomial. Okay. What's the degree? Show me the degree on your hand again. Show me the degree. I see the highest power on my variable is 2. Okay. So then this would be a quadratic binomial. Okay with that, everyone? Quadratic. Did I say bi? I meant tri. Quadratic trinomial. So far, so good? Good. Okay. Now, number 3. How many terms? 1 term. What's the degree? Do you see a variable? If you don't see a variable, the degree is 0. Okay. This degree is 0. It is a constant what? RJ? Constant monomial. And last but not least, this last one down here. Okay. And I want to take a guess at what it is. Classified by its number of terms and its degree. Show me a hand in the air. Okay. Mason, what do you think it is? You're close, but you got your descriptions backwards. Number of terms is not quartic. That's for degree. Okay. How many terms do you have? You have 4 terms. So what kind of polynomial is that? Look in your term table. Yeah, there you go. Now, what's the highest exponent on x? 7. So it's a polynomial of 7th degree. Okay? Because the highest exponent on x is 7. Okay? All right, good with that? Grab a picture of this. Okay. Questions so far? You're probably wondering when are we going to start adding and subtracting, right? All right, we're getting there. One more thing we have to discuss first, okay? Now, we've seen this standard form before, right? Remember when we talked about linear equations, one of the forms was standard form? AX plus BY equals C. We were talking about that way back last semester. Okay. Well, polynomials have a standard form also. Okay. When you write the terms so that the exponents are in decreasing order from left to right, your polynomial is in standard form. Okay. So that means the last term you should write, if you have it, is the constant term. Okay. If you don't have a constant term, the last term you should write is like the x term, and then the x squared term. Okay, that's the ones that you write last when you're writing them out. Okay, so get this definition in your notes. Take a picture here. Okay, and then we're going to go back to these right up here, and you're going to show me which ones are in standard form. Okay, based upon the definition. Okay. Does everybody understand what it means by decreasing order? You start with your highest determine the highest exponent, and work your way down until you have no exponent. Okay? So show me on your thumb. All right? Yes or no? Okay? Is number 1 written in standard form? Yes or no? What's the thought here? All right, you see the final answer? Everybody locked? Yes, it is. Okay? It goes from 3 to 1. That's great. That's what we want to see. Okay? It goes decreasing order. That's good. You can skip. If you don't have if you don't have a certain term, you can skip it. That's fine. Okay? But they still go in decreasing order, so that's standard form. Okay? How about number 2? How about number 2? Ready? It is a no. Good. Okay? How about number 3? There's only one term, so automatically it's standard form. Okay? All right, how about number 4? Okay. All right, so let's pretend for a minute that it's not, right? So, raise your hand, help me out here. If we were going to write number 4 in standard form, which term would be first? What?
X to the 7.
X to the 7. Okay. Then what would be next? Okay, Sadie?
X to the 5th.
Plus X to the 5th is positive. What's after that? Emily? Minus 2x to the 4th because it's negative. What's that the final term then, Toby?
Minus 8x to the 3rd.
There you go. Okay? That's how you rearrange it in standard form. Are you okay with that? You just start with the highest exponent, write that term, continue until you've written them all, and they're in decreasing order. Okay? Questions for me on this? Perfect. All right. So let's maybe indicate this here. I'll put like a little note here that 1 and 3 are in standard form. Okay? When you guys start adding and subtracting these, it will be very helpful if your answers were in standard form. Okay? It'll also be very helpful in some of the topics we're going to cover when we come back from break, too. That you have your polynomials in standard form. That will help out a lot also. Okay? Oh, excuse me. All right. Questions? Ready to move on? Are you guys ready to start adding and subtracting these things? Okay. So here's the thing. When we usually do this, I usually try to incorporate an application with geometry. There's not a lot of application with this stuff. So we use some geometry to get us started here and kind of get us thinking about things in the right frame of mind. We're going to skip all that this year. Okay? I'm going to cut right to the chase on a lot of these things. All right? So it's going to be more like me just saying, hey, this is what we need to do, and here's why we need to do it, and then we're going to practice it. All right? All right, so here's the thing. I'm going to try to find a clear space to work. Let's do it right over here in this little box. I'm going to make a blue box over here. Okay? We're just going to use it for a little experimental space here, okay? What is x plus x? Raise your hand. X plus x. Okay. Eliza? 2x. That is 2x. Okay, good job. Okay. Yeah, that's really 1x plus 1x, right? All right, good. Now, on the next problem, don't change the process, okay? Keep the process the same. What would be x squared plus x squared? Okay. Raise your hand. I heard somebody say it. Tony? Who agrees with Tony? 2x squared. Who thinks it might be something different? Anyone want to challenge 2x squared? X squared is the correct answer. Okay? A lot of people would say that's going to be x to the 4th, or has something with x to the 4th in it, like even 2x to the 4th in it. Okay? The question is, these are to the first power on the first one, right? Did you change the exponent in your final answer on the first problem when you added them? No. So guess what? You do the same thing when you have a different exponent on your variable. You don't change it. When you add, the variable carries over in your sum. Okay? So this is 2x squared. When do we change the variable? When we multiply, right? Remember our power rule from our product rule from a couple of topics ago? X squared times x squared is x to the fourth, right? Just like x times x is x squared. But if we add them, the power doesn't change. Okay? That's important. Because now you know how to add polynomials together. Okay? You ever talking about something called like terms before? Wonderful. Okay? Let's go down here and talk about like terms. When do you know two terms are like terms? Okay. All right. Turn and talk to your neighbor about this. Turn and talk to your roommates. I'm going to give you a full blank. Two terms are like terms if they what? Go. 30 seconds.
Yeah. 3.
Now, you guys know by now I can get through and cover all my dice at least once with you guys. Right? All right.
Exciting fear in your
Wait,
students.
you ready? I just have a feeling. No, I'm kidding. I don't know who's going to. Oh, I get the pick. Okay. Actually, it's Coleman's number. He gets even doubles this semester. I rolled double sixes. Okay. So Coleman, how did you guys fill in the blank? Two terms are like terms if they what? Have the same exponent or variable? I heard conflicting answers there. Variable. Okay. What do you guys think about that? Two terms are like terms if they have the same variable, right? Okay. So then I guess the question is, if that's true, can I add together x plus x squared? Can I do that? I can. What's the sum? Oh, but I thought 2x squared was x squared plus x squared. Remember, we just worked that problem a little bit ago, right? Okay. The key thing here, ladies and gentlemen, is that we have to expand our definition of like terms here a little bit. Okay. You guys are all correct. Two terms are like terms if they have the same variable, or in some cases, the same combination of variables. Okay. But now you've graduated. You're in the higher level now, so you have to expand your knowledge of like terms. So now we have to say this. Two terms are like terms if they have the same combination of variables raised to the same exponents. Okay? So that's where this helps us solve, add, and subtract a lot. Okay? Let's put this on here. So like terms. Two terms are like terms if they have the same variables raised to the same exponents. Are we okay with that sentence? All right, everybody got a picture of this? That once you bring your thumb if you're ready to move on. I'm going to go back up here to our box. Remember that little box we just did a little scratch work with? I'm going to go back up. We're going to do a little more scratch work here. I'm going to show you some pairs of terms in the box. And all you have to do is tell me if they're like terms or not, okay? So you should be a thumbs up for yes and a thumbs down for no. Are you ready? So here's the first one, okay? Negative 3x squared and 4x squared. Are those like terms? Yeah. Raise your hand, thumb up or thumb down. Do they have the same variables raised to the same exponents? Yes, they do. Those are like terms. Okay? The variables match, the exponents match. Okay? I can add and subtract those. Okay? How about this? How about negative 3x and 4x to the third? Are those like terms? Does everybody see the difference maker here? Yeah. Okay? You ready for a challenge? What if I give you one like this? What if I have x squared y in xy squared? Are those like terms? Do they have the same variables, but are the variables in each set raised to the same exponents? No, so these are not like terms. Okay. What about this set? What if I had a squared bc to the third and 5a squared bc to the third? Are those like terms? Yes, they are. Everybody see the differences now? Good. Because guess what, guys? Okay. Mm-hmm. Yeah. All right. So here's the deal. I'm going to fill in that first part in a few minutes. Let's go ahead and do an example first so I can kind of show you how this is going to map out, okay? So you guys see what you're going to have to do here, and then we'll go from there. So go ahead and get the examples down first, okay? We'll fill them out, and then we'll go back and we'll fill in the steps real fast, all right? Okay, so here's the deal, everybody. The first thing you need to do with these problems is mark your sets of like terms, okay? I like color. You know I like color. So I'm going to shade each one of these sets a different color. You don't have to go that far if you don't want to, but I do think marking them helps you get the right answer on these, okay? So either do multiple underlines if you have more than one set or different colors, whatever works best for you, but come up with a system if you don't have one already, okay? All right, raise your hand, everybody, on problem number 1 and tell me if you see a pair of like terms anywhere. From the first polynomial to the second one. They're enclosed in parentheses, okay? So the first polynomial is the first set, the first grouping, and the second one's the second grouping. Anybody see any like terms? Lance. 3x to the second power and 5x to the second power. Excellent. Are there any others? Okay. Yes. Good, good, good. Merrick? Yes. And you know what I should have done on this 5x squared? You guys just need to shade or highlight the sign before the term. Okay? Because that's going to tell you how they get combined. Merrick, what was yours again? Yep. Positive 4x. Positive 2x. If you don't see a semi-4 term, it's automatically positive, right? Read another one. Positive 3 and positive 1. Guess what, guys? What do you think you have to do to get the sum here? Combine the sets of like terms. 3x squared plus 5x squared. 8x squared. Yep. 4x plus 2x. 6x. 3 plus 1. Guess what? When you write the sum in standard form, the sum is 8x squared plus 6x plus 4. That is the final answer. We're finished. Manageable? That's all you have to do. Identify your pairs of your sets of like terms, add each individual set together, write the final answer in standard form, you have a polynomial. Okay? So we're not changing how we add, we're just doing it multiple times for the same problem. That's all we're doing. Okay? Let's try the next one. Okay? Let's try the next one. All right, so I need help. Blake, how about a pair of like terms? Can you find one for me, please, on number 2? Negative 5x squared and 2x squared. Very good. Okay. Another one, please. Tony. Positive x and negative x. Good. And I believe there's one more here. Okay. What? I did. Positive 2 and negative 9. Yep. Okay. So when you combine these together, okay, what's negative 5x squared plus 2x squared? Negative 3x squared. I'm just showing my work a little bit differently on this one, that you can show it either way you want to. Okay. X plus negative x, that's a 0. We're not going to have an x term in our final answer. That's okay. All right. Not every term will be represented in the final sum. Okay. And then 2 plus negative 9. Okay. So for the final answer, I get negative 3x squared minus 7. And we're done. Ladies and gentlemen, that's adding fractions. Adding fractions. Adding polynomials. It's Friday. Give me a break too. Okay? Okay? Think you guys can handle that on Monday? All right. Let's go back up and add the rules, okay? So you have those for your notes. Okay? So, rule 1. Combine all sets of like terms. And number 2, write the sum in standard form. Okay? See, adding polynomials. Sounds really intimidating, right? Is it? Polynomial operations. See, it's not that intimidating yet. We're just getting started. That's the problem. You think I have surprises for you next week?
Are we going to be combining these numbers too?
Maybe. Okay. Hey guys, we gotta hurry up and get through subtraction real fast, okay? So again, we're gonna start with examples. All right. Now, you can relate subtracting polynomials to subtracting integers. When you first learned how to subtract integers, for example, 5 minus 11, how did you change that problem so you then could find the difference? Remember how you did this when you were in 6th or 7th grade, in 5th grade? Okay. You made 2 changes to the problem. You know what 2 changes you made? The next to this sign became a positive sign. And then 11 became what number? Negative 11, right? And then you were able to add them together, correct? Well, guess what? You're going to do the same thing when you subtract. You're going to add the opposite of polynomial 2, okay? But that means then what you have to do is you have to change the sign on every term of polynomial 2, okay? And then you add them up. So the first thing you need to do, change your sign right here, and then opposite signs on number polynomial 2. So 9x squared becomes negative 9x squared, okay? 3x becomes what, class? Negative 3x. Negative 1 becomes positive 1. Now combine like terms and add them up. And that's how you subtract. Okay? So I have 6x squared and negative 9x squared. Okay? I have positive 5x and negative 3x. And I have positive 3 and positive 1. Okay? So, what is 6x squared minus 9 or plus negative 9x squared? Negative 3x squared. Okay? 5x plus negative 3x. Positive 2x. 3 plus 1. Ladies and gentlemen, that's your difference. Negative 3x squared plus 2x plus 4. You're done. Okay? Everybody see the game for Monday's assignment? That's all it is, okay? Now, here's one more thing real quickly. I know you need to go here real fast. If you have a polynomial situation where you don't have any matches to like terms, then those terms just fall into your final answer in standard form, okay? So looking at number 2 real quickly, you might notice that there is no other x to the 4th term, right, in polynomial 2. So then your x to the 4th term in polynomial 1 just carries over to your final answer. Okay? We'll put the rules up there real quickly first thing Tuesday, and then we're on the multiplying. All right? You guys have a wonderful weekend, and I will see you on Tuesday. Nice work, everybody.